So nothing is printed from the preceding statement to force the else clause to match the first if. You must use a pair of braces. Now they're showing the minimum you need to do. And of course I use the braces down here as well, just to be consistent. And then it'll print B. Okay, so common error is making a oh yeah, this is a very common error. If you do the semicolon after the if, then it's like not doing the if at all, really. It just ignores, this part doesn't get executed. So for compute area, if I accidentally put a semicolon there, then this thing, well, the problem is now we've got else. But if we go back to where before we didn't have the else, this whole thing gets ignored because the semicolon ends the command, and this is just treated as executable code no matter what. So we can see the difference. If I go in here and I put in a negative value, I get a weird area. It didn't check the if. However, if I go in and I remove the semicolon and run it again, put in a value, -2, now we don't get anything. Oops. And it works the way we expect it to work. So that's very difficult to debug too. This is another shortcut. It's called the tertiary operator. And again, I don't like showing all these shortcuts up front because they're not necessary, and eventually you'll learn them. But this is another shortcut for doing a very simple if statement. And there's a couple of different ways of doing the test of an if. You could say if the variable equals true, but that's not really necessary because an if statement is looking for a true for whatever question you're asking to evaluate to true or false anyway, so you don't really need to say that. You can just put in any Boolean. Let me see, I've got those. Ah. All right. Okay, we'll resume with this here. I'll create a new one. It'll be BMI. And it's going to ask you to enter the weight. Well, body mass index is actually not that difficult to do. Weight, let's just say 180 pounds. Height in inches, 60 inches is 5'10", I think, if I'm not mistaken. Your BMI is 35, you're obese. Maybe it's not. Oh no, that's 5 feet. We should have said 72 for 6 feet. Sorry. Let's just say 180. Let's see. 80, and 72. Okay, these are normal. So it's a fairly straightforward calculation. The BMI is a calculation of the weight and the height to see if that's your body mass index. Yeah, so those are pretty simple. Computing taxes. I go through all these complex ones there. Let's see where we're at. Yeah, it's calculated based on a certain income and bracket here, and these are going to be a similar thing. You're going to enter in your income, and you can download this code yourself and look at it. But based on what your filing status is going to determine one thing. How many deductions you can have and what bracket you're in. And it's going to work similar to BMI, but it's going to be much more complicated. Okay, so logical operators. This is when you get more complex and you start asking. Well, there's a couple of operators. One is the not, which simply switches around the true or false. So if something evaluates to true and then you say not, that just means it's no longer true. It's now false. Like raining or not raining. So if you say raining, it's raining. If you say not raining, it's not raining. So it works a similar sort of way. And then the double and percent is a way of saying and. So, for example, the rules of getting into a bar with cover charge might be age greater than 21 and $10 to pay the fee. So that would be a complex question. So in order to get into a bar, you've got to be 21 and have the $10 entrance fee. Or means one or either of the questions has to be true. And then exclusive you almost never use, but it's a variation on or. We'll look at those. Again, the truth table for the operator. True, not true is just the opposite. It's false, and then false and true are the opposite as well. And then when you say and, basically what it means is that both questions have to be true. So it requires both questions to be true. The OR operator, or the double bar is the OR operator, basically is just the opposite. It requires that one of them be true, but not both. Now, the exclusive operator is a variation on true. Basically, what it says, it wants just one of them to be true. So with OR, you could have either one be true or both. With exclusive, it's got to be just one true and just one false. So they're exclusive of each other. You don't see this very often, but it is sometimes helpful. And you can have some questions. Here's a program that checks whether a number is divisible by 2 and 3. So we could do that fairly easily. So I think we had that in one of our things here. So we can answer a number here. So this would be, it's 2 and 3, right? So it's fairly straightforward. We just say if answer is divisible by 3 and ANS percent 2 equals 0, then our answer would be, high 5 or whatever, if it is. Otherwise, simply So that would simply take care of that one. We run it. Integer, so if I enter 6, the answer would be yes. If I enter 9, then it would be no, because it's not. Right, so they're essentially doing the same thing that I'm doing here. They're using these shortcuts a lot, and I don't like that for beginners. Ignore these shortcuts. And then if you wanted to say, is it divisible by both but not, or you could say, is it divisible by either or, then you just simply change this to that, and then anything divisible by one or the other will be work. So 9 now will give us a positive answer because it's divisible by 3. Let's see, 4 as well, right? And 6 again. But to show you how the exclusive would work, 6 actually would come back false in this case, because it can't be both. It can be one or the other, but not both. Not divisible. And we should change that or. Okay. Any questions on any of these examples? The AND and OR operators, these are variations on the double AND and double OR. Basically, if you're in a situation where you're looking for an entire question to be true or false, you are Java is going to efficiently ask that question as possible. So, for example, if the first part of this is false, then it's not going to bother going to the second part normally with a double ampersand. But with a single one, it will. Whereas the double ampersand, it won't. So, fairly straightforward to test, something like this out. We'll just do it this way here. If I greater than 1, single ampersand plus I less than 10, we'll print the output on this. I'm just going to say done because this is not really important to us. The important thing is what's the value of I. Two. Okay, so with a single ampersand, the entire thing gets evaluated no matter what. Even though it technically did not need to go to the second part because I is 1, it's not greater than 1. Now, however, if we do this with the double ampersand and run it, we'll see that I will be 1 this time. And the reason for that is that we've got a couple of options. Now, the original one was to do both, to always run the entire thing, ask the entire question, even if the first part is false and the rest of it can't possibly be true. And that was kind of inefficient. So they came up with a new one that said, well, if we don't need to evaluate the entire question, why should we bother? So that was the double ampersand. It's a little more efficient on processing, but there may be circumstances where you actually want to ask the entire question because some additional processing is going on in there. So, and you want to make sure that processing happens no matter what.